Okay, so to do this, you undo addition and subtraction first. So look at the side with the variable's on the right. Do you see any numbers that are added and subtracted?
Yes.
Which one?
4 and 8.
Four. Well, the 4 is multiplying the x. The 8 is being added. So how do you undo plus 8?
Divide.
You undo, so let's review here. You undo addition with subtraction, and you undo
Oh,
subtraction with addition. So there's a plus 8 here. You're going to subtract 8 from both sides of the equation. What is 20 minus 8?
um, 20 minus 8 is 12.
12 equals. Now, these go away. The 8 and the minus 8 go away. So what is left over on the right?
Um,
If
4,
the 8, what else do you see?
4,
What about this letter to the right of it?
x.
4x. So 4x remains. So when you subtract, it goes away. Does that make sense?
Yeah.
It's gone. So now the 4 is multiplying the x. Okay, so how do you undo multiplication? You undo multiplication with division. You undo division with multiplication. So the 4 is multiplying the x. How do you undo multiplication?
Division.
So we're going to divide both sides by 4. So you use a fraction bar instead of division. So what is 12 divided by 4?
Um, 3.
3 equals x, or equals 1x, but it's really x. Okay, so we're going to actually do 4a next because it's very much like what we just did. Is that okay?
Yeah.
All right. And then I might give you a few more to try, but there's a lot here, so we'll see if we can get all this done. So this equation, you first look at the side. First thing you do is look at the side with the variable. So the variable's on the left side. So you look really hard at the left side, and you say, okay, what do I see? But 7 is multiplying the x, and this is subtraction by 4. So which do you undo first? Well, we said in the previous problem, you undo addition and subtraction first, then multiplication and division. So how do you undo subtraction by 4? What is the opposite operation?
Addition.
So you're going to add 4 to both sides. Tell me what to write on the left side or the right side.
Um, um, would it be 8 equals 28?
So minus 4 plus 4, they undo each other. Like you had 4 things, then 4 things went away, or you had $4 and you lost $4, or something cost $4 and you pay $4. How much do you have left over?
0.
0. So what you could write is 7x plus 0. But what is what is anything plus 0?
That number.
That number. So what remains on the left?
Um, 7.
What about this letter?
Um,
Like it's just like the previous problem, right? You tried doing the same thing. You said, oh, it's 4. And I said, no, what's the letter? The letter comes with it. Like these are tied together.
oh, um, 7 divided by.
It's just, you're just bringing it down. You're just bringing down that number.
Hmm,
Okay. How about on the right side? 24 plus 4. What does that become?
28.
Okay. Now, what is the 7? What is the math operation between the 7 and the x?
You just divide.
Well, you undo it with division, but what is the math operation between them? Like when they're squeezed together like this.
Um,
I mean, you gave me the right answer. You undo blank with division. So I'm just asking for this operation here. I want to make sure it's clear you know why you're dividing. Why are you dividing? It's because these two numbers are, and what's the math operation between them?
um, I don't know.
You just got to look at what's here. You undo, what does this symbol mean?
Multiplication.
You undo multiplication with division. So yes, you're going to divide both sides by 7 because 7 is multiplying the x. Right? So what is 28 divided by 7?
Um, 4.
It is 4. Very good. Okay, so let's try some more basic problems here. These are not on your worksheet. Let's try some more basic ones. Let's say it's x minus 3 equals 2. Look at the side with the variable. How do you undo subtraction by 3?
You add
Add. What are you going to add to both sides?
3.
Okay, so add 3, add 3. Tell me what goes on the left or the right.
Um, 0
On the left
and
or the right.
5. 0 on the left and 5 on the right.
Okay. Is there anything else that goes on the left?
Um, yes.
Okay. What
X.
do you're bringing the x down, right? And then, like we just talked about, when you're adding 0, that doesn't contribute anything. So x equals 5. Let's try another one here. Let's do 54 equals 9x. Which side is the variable on?
The right.
Okay. So what is the math operation between the 9 and the x?
You bring it down and it becomes division.
So
And divide.
there's 4 math operations: add, subtract, multiply, and divide. I'm asking you not how you undo it. I'm asking you what it is between them.
Multiplication.
Multiplication, right? And you undo it with
Division.
division. Tell me what this equals, please.
Um, 54 divided by 9 is 6. And then
What does it?
9,
Yeah, what does
and
that
then
become? What is 54
um
divided by 9?
6.
6. Good. Okay. Let me have you try a couple here on your own, okay?
Would the one on the right be 13?
Yes, subtracting one from both sides. Martha. All right, yeah, x is 13. How about on the left? What are you going to divide both sides by?
Um, 3.
Good.
Mm, would it be 1?
How about just 15 divided by 3? What does that become?
Oh, it's 5.
Okay. And then you bring the negative down. Is that okay? All
Yeah.
right, let's try a couple more here, and then we'll get back to your assignment. Okay, give this a try, please. Give me just the final answers.
Would the one on the left be 13?
You are adding 4 to both sides, but one is positive and one is negative. We were doing a bunch of problems. It's like 9 down and then 4 up. It's like you first have to figure out whether the answer is positive or negative.
Negative.
It's negative, and then you take the larger number and subtract the smaller.
5.
It's 5, so this becomes -5. Good. Okay. All right. You want to try this one on the right here, please?
Would that one be 6?
Yeah. So you're doing real well on the ones that are, positives. Only issues when we mix some signs. But let's get back to your worksheet here. What I'm going to do, we're going to do this a little bit out of order. We're going to do 6 next, and then we're going to go back and do some other stuff. It will make sense. This is how normally it would be taught in a classroom. So, all right. It says use the distributive property to write an equivalent expression. So distribute means to give out. It means equal. Everyone gets the same thing. So this 5 is going to go to both the x and the -3, and you're multiplying. Do you remember that from class?
Yeah.
Okay, so it's really 5, and then it's 1x minus 3. The 5 is actually multiplying the 1, and either the 3 or the -3, depending on how you look at it. So could you give me the answer here?
Yeah. So wait, so you're multiplying 5 and 1 and 5 and
Yep.
negative 2?
What is 5 times 1?
5.
So it becomes 5x. The x goes with it. What is 5 times 3?
15.
Right. And so that minus, see how that minus operator goes with it?
Yeah.
Okay, now you try one. What does this become?
Um, 6x minus 30.
Very good. Okay. All right, so now let's look at the next one on 6. Right. So this time you're going to take that 4 and you're going to multiply it by the 2 and the 6. So can you tell me what this becomes, please?
Um, eight AX plus 24.
Very good. How about 3 times 5x minus 2? Can you tell me what that becomes?
15x minus 6.
Very good. All right, so now we're going to go back to 4b. I know this is out of order, but it will make sense now. So 4b, okay, you're going to first multiply that 3 inside. So we did a problem like this. If you've got it written down, I can scroll up if needed.
Um, 3 times 1x.
Okay, what does that become?
3.
Anything else?
And then you add, and then, I mean, 3x plus,
Good.
24.
Okay. All right, now this is a two-step equation. And you solve a two-step equation by first undoing addition and subtraction. So you look at the side with the variable. What's the side with the variable? It's the left side. What number is being added?
24.
So how do you undo addition by 24?
Subtract.
All right, so what does the left side become?
Um, 0.
Nope. Look at what's on the left side. There's the previous line. Like you can't just disregard what was there. You have to bring everything down.
Um, 3x, um, plus 0.
Yep, or 3x, because this equals.
Um, 3. I mean, wait.
Good. Now, how do you undo the 3 in front of the x?
You divide.
Divide by 3. What does the right side become?
Uh, 1.
You got it. Okay. Any questions on that?
No.
Okay. Now it would actually be really good for us to spend the rest of the lesson on working on this type of stuff we've been doing, but we can't do that if we want to get through everything. So we will unfortunately have to move on here. So we're gonna go back to number 2. What do you see here? Tell me kind of what you see visually. There's no right or wrong answer here.
S plus 6 5 times.
Exactly. So that's 5 s plus 6's. Okay. So you said it perfectly. Like we don't know what s plus 6 represent, but there's 5 of them. Okay. So I guess we got to look scenario by scenario here and see which one gets us back to that. All right. Noah walked a family dog 5 times this past month and earned the same amount each time. To thank him, the family gave him an extra $6 at the end of the month. So let's say what he was paid was S. So the first time he walked the dog, how much money did he get?
Um, S.
Yes. And the second time he walked the dog, how much money did he get?
6.
Nope. That was at the end of the month.
Um, S.
Okay. And the next time, how much did he
6.
get paid? Nope, that's at the end of the month.
S.
Yes. Yeah. And then
Oh,
S and then
I get
S. And then at the end of the month, he got 6, which totaled 106. Okay. So this part right here, how many S's is it?
5.
5S plus 6 equals 106. Is this the same? Has to be exactly the same as the previous line here. What do you think?
Yes.
It looks like it because it's got a 5 and that's in a 6. But what do you do with the 5 on the outside? What have we been doing in all those problems leading up to now?
Um, 5 plus 5x, 5s plus 30.
Right. Is that the same?
Yes.
It is.
Oh, no.
Yeah. I mean, you gotta look carefully, right? It kind of looks like it's the same, but it's not. So is that the same? No. But it looks like it could be. Okay. Let's look at situation B. All right. A family of 5 drove to a soccer game. They paid $6 for parking, and all of their tickets were the same price. So we're going to call their tickets S. So each person that went to the game needed a ticket. And we know that the tickets cost S. We're calling it S. Is that clear?
Yeah.
Okay. So how much was the first ticket that they needed?
S.
S. And the second,
S.
and so on, right? Now, did they each pay for parking? I mean, I'm sure you've been to a sporting event, maybe you've even been to a 49ers or Cardinals game. Um, does everyone in the car pay the parking?
Um, yes.
So that would
Wait.
be they would love that. I mean, they'd love if they had to pay, but it's the car. Only the car gets charged. So you can think of this as the people
Um,
and then the car. So you try to get as many people in the car as you can when you go out there. All right. So is this the same? Is this the same as the original?
um,
This is
yes.
5S plus 6 equals 106. Is that the same as what we started with?
Yes.
It is?
Oh, no.
Okay. All right. So this one's out. Which means it's one of the next 3. Next one's weird. All right. So I want you to look at B and E and see if you can figure out, you know, which one which one is correct. And you can do it one of 2 ways. You can figure out which one is correct, or you can say, oh, this one is wrong, so it must be the other. It's not C. Actually, I take that back here. We need to look at C. But go ahead and look at these 2. Decide if either of these are correct, please.
D is wrong.
Okay. What about E?
Um, E is right.
So let's take a look at these one more time here. Right? I feel like maybe I missed something here. It says K is baking 5 batches of muffins. Each batch needs the same amount of sugar, so we'll call that S. The amount of sugar is S in the muffins. But then she's going to add 6 to each batch. So for the first batch, how much sugar does she need?
S.
Plus 6. And then how much for the second batch?
Um, S.
She needs S again, but each batch also requires an extra 6. Is that okay? Is that
Yeah.
clear? I'm just reading, I'm getting all of that from, so what we're really looking for in this scenario is something where you need some amount, S, and then you need an extra 6 each time. All right. And then how many S plus 6s are there in this problem?
5.
There are 5. So 5 times S plus 6. What does this equal? Is this the
Um,
same as the original?
yes.
It is. So this one works. All right, so let's take a look at E now. You said E worked. Let's take a look at it again. All right. Priya buys 5 cases of water, each with the same number of bottles of water. So we'll call the bottles of water S. The store clerk gives her an extra 6 bottles before she leaves. Now, is that for each case, or is that just a one-time extra 6?
Um, for each case.
The way you read this is that the clerk gives her an extra 6 bottles each time for each case.
Oh, no.
No. So it's like S plus S plus S plus S plus S plus 6. That's 5S plus 6. Is that the same as the original?
Um, yes.
It's the same as the one we've been.
Oh, no.
Okay, that's like the third time you've not really noticed the difference. Like, are you going to give me a good 15 minutes here, or should we just stop the lesson here?
I'll give you a good 50.
Okay, I would really appreciate that. And I know these aren't that easy to do. I'm really trying hard to help you work through them, but you got to give me a little bit better effort. So let's try and do that here for the next 15 minutes. 5 bags of coins each contain 6 nickels and the same number of pennies. So picture here would really help. There's some number of pennies in each bag, but what does it say is also in the bag?
Um, 6 nickels.
6 nickels. So we'll call that plus 6. So each bag has that's in there, but they've also got 6. All right. So how many bags of coins are there total?
5.
Five, right? So we got five S plus sixes. Is this the same as the original?
Yes.
It is. Very good. So we know the answers are C and D. All right. We're going to keep going here. Some of the next one should go a little faster. Plus, you've already done some. All right. Uh, New question here. Over the weekend, Jada made 3 times as much money from babysitting than Han did mowing lawns. Jada made an additional $27 selling lemonade from babysitting. That's selling lemonade. She has a total of $96. In the equation, 3x plus 27 equals 96 represents the situation. What does the variable x represent? So let's read it one more time now that we know what we're looking for. It says over the weekend, Jada made 3 times, so there's the 3, as much money from babysitting than Han did mowing lawns. She made an additional $27 selling lemonade. And in total, she made $96. Okay. So there's the 3 numbers, the 3, the 27, the 96. What does the 27 represent?
Um, um, the dollars of how much she got from selling lemonade.
That's right. So that's the lemonade. 96 is the total. So we know the three is how much she got from 3x is how much she got from babysitting. But it says 3 times as much that Han did. So they're asking you to figure out what X represents. It's what I've highlighted there. What does that become?
Um,
How would you put that in your own words? Like let's put a number. Let's say Han made $4. How much did Jada make?
um, 12.
12, 3x, right? So how do you get the 12 from the 4? You multiply by
3.
3. This is the x. The x is the amount that Han made. So you've got to put into your own words something down like that, please. So go ahead and put something down. Let me know what you come up with.
Or what X represents.
Yes.
Um, X represents multiplying by 3.
Nope, the three is the multiplying by 3. X is the number that you multiply by 3. So that's what you have to say. Um, But I tried to give you an example. I said, we said, what if Han made $4 mowing lawns? You get to 12 by multiplying by 3. That's the 3. So 4 represents what X represents. What does the $4 represents? And I've highlighted it here as well.
How much money babysitting, or I mean, what, um, how much money haunted mowing lawns?
That's right. That is the answer. So I would put exactly what you just said down on paper, please.
Okay.
Let me know when you got that down. We'll move on to this question.
I got it down.
Okay. So here are two situations. For each situation, draw a tape diagram. We actually were doing this in question 2, so it won't be that difficult. Um, it says for each situation, we're going to draw it. So the tapes are like these things, I guess. That's what teachers using. Does that sound familiar?
Yeah.
Okay. Um, so it says 5 students came for an after-school tutoring. Lynn's teacher assigned each student the same number of problems to complete. So we're going to call the problems X. I guess we can do, let's use X for the number of problems. So student 1, how many problems did student 1 complete?
Um, X.
X. Now let's keep reading. Then he assigned each student 2 more problems. So what should we add to this?
Um, plus X.
Plus how many?
2.
2. Yeah. Now how about student 2? How many problems did they complete?
30.
Well, in total, they got 30. But student 2, it says 5 students came and they completed the same number of problems, but then each did 2 more than that. So let's start with how many problems did student 2 complete before the 2 more? Think of this as like, just pick a number, like 4. Each student completed 4 problems, then 2 more, but the 4 is really the X.
So, oh,
Yeah. So they're all doing the same thing. Like it's like every student has to do the same number of problems. So how about student 3? How many did they complete?
X plus 2.
X plus 2. Good. Okay. And then the next student, how many did they complete?
X plus 2.
X plus 2. And then X plus 2. So how many X plus 2s do we have?
5.
So it's 5 times X plus 2 equals 30. Now look back at what we did in 4B, problem 4B. What's the next thing to do here with the 5?
Multiply.
Yes. So tell me what it becomes when you multiply this 5 in.
5x plus 10.
Good. Equals 30. And now you're going to undo addition and subtraction first. So look at the side with the variable. What number are you going to undo first? The 5 or the 10?
The 10.
Okay, so 10 is being added. How do you undo addition by 10?
You subtract.
Subtract 10 from both sides. So 5x equals what number?
Um, 20.
20, good. And then how do you undo multiplication by 5?
Divide.
Divide by 5. So what does x equal?
4.
Good. All right. Let me know when you get that down. We should be able to finish part B here.
I got it down.
Excellent. All right. 5 students came for after school tutoring. So it sounds really similar. This previous teacher assigned each student the same number of problems to complete. So we'll call that X. Then she assigned 2 more problems to one of the students. So does every student get 2 more in this example?
Um, no.
How many students get 2 more problems?
1.
That's right. So here are the 5 students. Make the tape diagram again. Okay, so how many problems does the first student get? What letter are we using for that?
X.
Okay. And are you going to make this one? Do you want to make this one the one that gets 2 more or not? It's up to you.
Uh, no.
Okay. How about the next student? How many problems do they get?
X.
Okay. X. And how about the last one?
2.
Only 2? Is that all they get?
X plus 2.
X plus 2. Very good. So how many X's do you see?
5.
5. And then you add 2 to get 27. So this is a problem like we've been doing up until now. You undo addition and subtraction, and then multiplication and division. Take a minute and see if you can solve this for me. If not, we'll do it together.
Um, would it be 15?
So when you subtract 2,
Oh,
you get you get 25. And then how do you undo the 5 in front of the X?
you divide.
Divide. So what does X equal?
Um, 5.
5. Very good. Okay, we're going to stop there for today, Lennon. Good job. Good effort the last 15 minutes, like we talked about. So next Sunday will be our last lesson for the year. Until next year, we'll figure out the schedule, but that is it. Good job. I will see you next week. Hope you have a great rest of your day.
Okay, you too.
Thank you. Bye.